Right, this lesson we're going to look in a bit more detail at circular motion. So, features of circular motion. Right, first things first, right, this is when something moves in a perfect circle. Now we see this with planets orbiting stars, moons and satellites orbiting planets. All right. Now the thing that makes it move in a circle is a force. It's a force towards the center of the circle. Now the force is always perpendicular to the direction of movement of the object. So if we look at the blue object moving in a circle here, there's a force on the blue object towards the red object. Okay, but the blue object is moving at a tangent to the circle. Now, one really important factor I just want to share with you here is, although this blue object is moving at a constant speed, it's covering the same number of meters per second, its direction is constantly changing. So if its direction is constantly changing, it is constantly changing velocity. And if it's changing velocity, it must be accelerating. Okay, so it's actually accelerating towards the center of the circle. Okay, so there you have it. So speed is constant, but velocity is always changing because the blue object is changing direction. Now, this is what we see when things move in a circle. Okay, when things are, certainly planets are orbiting stars and so on. So we can draw that quite nicely on here. So basically, there's always a force towards the center. Now that force is called the centripetal force. All right, let me just write that for you. So centripetal force, and what that means, that's not like a type of force. That centripetal force is just the force that makes something move in a circle. Okay. Now the centripetal force can be many different types of force. For example, if we have, I think this is the London Eye in London, and the thing that's making these little cabinets move in a circle, okay, is there's going to be tension in these spokes. So there's these metal spokes, which are like bicycle spokes on a wheel. Okay, so they're going to make that move in a circle. So let's have a look at some other examples. I want you to think about what's providing the centripetal force in each of these cases. Here we have it. There's a rather simplified diagram of an atom. We've got the nucleus in the middle, and we've got electrons orbiting. Okay, what's the force that's making those electrons move in a circle? Okay, now it's actually the electrostatic attraction between the positive nucleus and the negative electron in this case. Okay, there we have the hammer thrower, an Olympic sport. What's making this ball move in a circle? You'd be right if you thought it's the tension in the string that's moving, that's in a direction towards the center where this guy's hands are. Okay. The roundabout. If you're a child on a roundabout, what's going to be pulling you towards the center as you move in a circle? Well, it's going to be the pull. If you hold on to these yellow bars, it's going to be the pull from the bars towards the center. Okay, some kid throwing his younger brother around. Okay, what's the force that's pulling the little guy towards the center? It's going to be the tension in the arms, isn't it? So again, tension. Tension is a very common centripetal force. It's tension here, isn't it? Tension in these wires. Okay, tension in these wires, which is towards the center of the circle. Okay, here's a different one. What's making this car move in a circle? Any ideas? Right, it's the friction. It's the friction between the tires and the road that's making that car move in a circle. What about a galaxy, a whole rotating spiral galaxy? What's going to be the weight of the galaxy? It's going to be the weight of all those stars that's going to be pulling towards the center where most of the mass is. Okay. What about this record on an old-fashioned turntable? Okay, ask your mum and dads about them. What's making that record, that 12-inch record, move in a circle? Okay. Well, you notice this thing here. There's a little spindle that goes to the middle of the record. That's going to be pulling the record towards the center of the circle. Okay. The London Eye again. We had that. Okay. The thing that's moving. The cabins are in a circle. There's going to be tension in all these spokes. And finally, this is one we've already talked about. What's making that satellite move in a circle? It's the gravitational pull of the Earth on the satellite. So there you have it. It's the centripetal force and circular motion. Right, I've got a little video for you to watch now of me demonstrating with various masses on strings. We're going to look at the centripetal force in a bit more detail. So thanks for listening.